All right, guys, this little video is just for anybody that needs a little review session, basically. So for our first quiz, it's going to be all on circle angles using these different rules. So the first thing, angles. Oops, let me slide that over. All right, hello, my geometry students. Here's a chance to just get all the rules down in one place. So for the angles, we should know that a central angle, which means the vertex is on the center point, is the same measure as the arc it opens up to. An inscribed angle, which means that the vertex is on the circle itself, is half the arc, or the arc is double the measure of the angle, however you want to say it. The next one, the tangent chord angle, literally is formed by a tangent line and a chord in the circle. Same rule as an inscribed angle. It's equal to half the arc. Oops, which I guess I could put back up here. That's just equal to the arc. And so in this case, this would be our 2x. For an in angle, that really means you have two chords that intersect and the vertex is kind of floating around inside the circle. It is the average of the two arcs. So arc 1 plus arc 2 divided by 2. For an out angle, it's the difference of the two arcs. So big arc minus small arc, or based on the way it's labeled, I'll say arc 1 minus arc 2 divided by 2. The last little rule that we could sneak onto this page that's not on here, but it should be, is a cyclic quadrilateral. So if you have a little space here, give yourself a circle, and then draw a quadrilateral inside of it. And so if you can remember, for a cyclic quadrilateral there, the opposite angles are supplementary. So in my picture, if this is one angle, the angle across from it, let's say angle y, angle x plus angle y would have to be equal to 180 degrees. All right. On the back, there's more. So on to page 21, the circle theorems that we should know is that if chord AB is congruent to chord CD, so if those chords are congruent, then that means that arc AB is congruent to arc CD. And so their measures will be the same. If you have parallel chords, so EF parallel to GH, then the little arcs that they kind of cut out on either side are equal to one another. So I can say that arc EG will be congruent to arc FH. And then the last reminder here, right angles in circles. So in this picture, this is a tangent line, AO, that is a radius, and the tangent and the radius are perpendicular to each other at the point of tangency, so at point 8 right there. So the tangent is perpendicular to the radius. All right, for this one, if you have an angle inscribed in a diameter, it is a right angle. So it's important to note that AC there is the diameter. And so this inscribed angle right here, oops, I just made up my own spelling. You can write it correctly on your paper. I'll fix it here. So that inscribed angle has to be equal to 90. Right? And the reason is because it's half the arc it opens up to. There's that arc of 180. All right, last one here. If you have a radius that is perpendicular to a chord, so if the radius is perpendicular to a chord, then it bisects the chord. So that means we get those two little equal parts. So this is one of those questions, just as a little reminder that it's great to draw in the radius and you create a right triangle, so you can use Pythagorean theorem. All right, so there's a quick little rundown of all the rules that you should have. As for the rest of them, I'm going to do a couple more. Feel free to watch through if you like. So the very first one here, when it says find the length from K to J, what we're looking at is that scenario where we have a chord perpendicular to radius, so it's bisecting the chord. And so I can draw in that entire radius there, because if this is 3 and that's 4, the full radius length would be 7. And now it's asking you to find KJ, but for right now, I can find half of that here. So if I make this A, B, and the C would be the 7 right there, then I'm looking for the B value. So I'll put like a little X there. So I can do A squared plus B squared equals C squared, or 4 squared plus X squared equals 7 squared. So this will give me 16 plus X squared equals 49. If we subtract 16 from 49, that'll leave us with X squared equals 33. When you take the square root, you already know that's not going to be that pretty. But we get 5.74 and change. But that's half the length we're looking for. KJ is double that. So now if we go times 2, so keep in mind, I'm not done with the question. I'm not rounding a darn thing yet. So double it, I get 11.48 and so on. That is what I would now want to round to the nearest tenth. So 11.5 would be the length from K to J. All right. The next one I wanted to take a look at is not on this page, but down onto the next page. I know some of these are a little tough to read. Number 6 says find the angle measures of the inscribed quadrilateral, given that the measure of angle G is 10M, H is 5M, and I is 8M. So in case you can't read them there, you can see it here. All right. In this case, an inscribed quadrilateral means that we're looking at a cyclic quadrilateral. And the rule is that the angles opposite of one another are supplementary. So in this picture, angle I and angle G, those are opposite angles. So we can say that 8M plus 10M has to be equal to 180 degrees. So if 18M equals 180, we can divide, M's going to come out to be 10. So now we're just plugging on in. So that makes angle H 5 times 10, or 50. Angle G, 10 times 10, so 100. Angle I, we got 8 times 10, or 80. And then the last one, you can still use the idea that we know a quadrilateral total degrees is going to be 360. So right here, we've got 100, 150, 230. So if we take 360 and subtract 230, we've still got 130 degrees left for that last little angle there. So lots of things you have to put together to be able to answer that question. All right. The next page, you've got more of the same type of questions. Here, just as a reminder, some of these you may have to work backwards for. So like one like number 14, this, if you look at it, you have 2 chords intersecting. That is an in angle. And the in angle is the average of the 2 arcs. So 88 is equal to x plus 100 divided by 2. And so then if we multiply the 2 out, grab my calculator just to make sure I don't goof anything up. So 88 times 2, I get 176. And then you can subtract 100 over. And so that missing arc should be 76 degrees. Please make sure on your test, show the work when it's, partial credit questions, especially if you want to get full credit, or if you make a mistake, you can still get partial credit. All right, I'm thinking back here. Let's do one big circle question, and then we'll end the video there. So it's saying in the diagram, you've got a tangent line, You got a secant line, and let's mark what they're giving us. So angle P is 40 degrees. And then arc CD, so this little guy, to arc DA, that guy, is in a ratio of 1 to 8. So whenever we see those ratios, we can tag an X in there and make it 1X and 8X. And now if we look, that is exactly half the circle because this is a diameter passing through that center point. So off to the side, I can know that 1X plus 8X has to be equal to 180 degrees. And then if we divide it out, X is going to be 20. So what that ultimately means for us is that this arc is 20 degrees. This arc is 8 times 20 or 160 degrees. So that's actually the first question down here, is to find the measure of arc DA. So that's 160 degrees right there. All right, for arc AB, these are sometimes asked in a very particular order so that you can use what you just did to get there. So what I mean by that, let's see, we know that this out angle is 40, and it opens up to 2 arcs here. I'm going to highlight the 2 arcs it opens to. Arc AB, and then arc AD. So if we do the work here, I'm going to call this guy just, Y. I know that that out angle of 40 is equal to the bigger arc minus the smaller arc divided by 2. So double both sides. This is going to give me 80 equals 160 minus Y. And then if we rearrange some things here, I'm ultimately going to end up with Y equals 80. At first, it gives me negative Y equals negative 80, but you guys get the deal. All right, so that's going to give me 80 degrees right there. All right, angle BEA. So BEA in my picture, this is an in angle. And so for an in angle, average the 2 arcs it opens up to. So now we know the 2 arcs. You've got the arc of 80 right here. And then its vertical angle opens up to that little arc. That's 20. So it's the average of those 2 arcs right there. So 20 plus 80 over 2. That'll give me 100 over 2 or 50. And then again, mark it in the picture because you might need it for the next part. All right, angle BAC. So BAC, BAC. All right, think about where it is. BAC, the vertex, is on the edge of the circle. That's an inscribed angle. So for an inscribed angle, it's equal to half the arc it opens up to. Right? So look at the picture. The arc that this guy opens up to is the last arc that we haven't talked about yet. But we know everything we need to get it. So to get that last arc, we're going to go 360 minus all the other arcs that we know. 80, 160, and 20. So that's a total of 260. So we're left with a 100-degree arc right there. All right, so now that we have it, angle A is half of 100. And so keep in mind, notice how sometimes I'm doing my work down here. Sometimes it's off to the side. You want to try to keep it organized, but as long as it's there, I will find it. All right, last part, PBA. I like this question because if I look at PBA, that's not any type of angle. Yes, the vertex is on the edge, but it's opening out. And it's not, the 2 sides aren't chords in the triangle. So this doesn't actually fit any one of the rules that we know. So what we have to do instead, is find something else we could use. So I could look at the fact that I have a triangle right here, or maybe I want to look at the angle that's next to it. This guy right here is an inscribed angle that opens up to that big yellow arc over there. So if this arc is 160, this angle has to be half of that, or 80. These 2 form a straight line together. So if this is 80, I can subtract from 180, and that has to be a 100-degree angle. So lots of ways to get there, but the cool thing is it should all match up no matter what. All right, that's it. I hope that helps. Keep on working on the rest of those questions.